Welcome to another episode of The Inquisitive Engineer. Have you ever wondered why tungsten is used in the welding process? If you do a little bit of welding yourself, you may know the three common types of welding. Or if you're not familiar with welding, you may have heard some of the words like stick welding and MIG welding and TIG welding. So let's take a look at these welding processes and see just why tungsten is used sometimes in the welding process. Let's first take a look at stick welding. In stick welding, you have a metal rod that is about 12 to 15 inches long and coated in flux. This flux chemically reacts in the heat of the welding process to produce gases that shield the molten pool of metal, primarily from oxygen and the formation of ferrous oxides and aluminum oxide compounds. After all, the air we breathe is about 21% oxygen. This metal rod is called a consumable electrode. It melts and fills the gap between the two pieces being welded together. This process of welding was very popular for decades as the welding equipment was fairly simple. It does take some skill to learn how to control the feed of the electrode as it is being consumed. Personally, I'm not very good at stick welding. This leads us to MIG welding. MIG welding stands for metal inert gas. The equipment for MIG welding used to be prohibitively expensive, but over the last 2 decades, the cost really has come down, and many hobbyists and at-home welders now own a MIG welding system like myself. In a MIG system, you pull the trigger of a gun, and the equipment feeds a thin wire of metal at a consistent speed. It also delivers bottled shielding gas through the gun to protect the weld pool from oxygen. It's rather easy to learn MIG welding as you simply adjust the feed rates and amperage rates via some knobs on the equipment and you just pull the trigger and off you go. This, like stick welding, also uses a consumable electrode. And inside your MIG welding machine is a rather large spool of consumable electrode wire that is typically 0.024 inches or 0.035 inches in diameter. This brings us to TIG welding. TIG welding stands for tungsten inert gas. In TIG welding, you see that the welder is holding two separate items, when in stick welding, it was just a single electrode, and in MIG welding, it was just the welding gun. So what's going on here? Well, in TIG welding, you have a non-consumable electrode and a consumable filler rod. The electrode must supply enough current to generate heat to melt the base part and the consumable filler rod, but not melt the electrode itself. Therefore, the non-consumable electrode needs to have a high melting point. If we look at the highest melting point of elements on the periodic table, you see that carbon and tungsten are a cut above the rest, with some honorable mentions that are expensive rare earth metals, so they are not practical for use. You may ask yourself, why not just use carbon? After all, carbon is cheap and readily available. While this is true, carbon is also very brittle. It is extremely easy to bump your electrode during the welding process and break it. Carbon also sublimates at the high temperatures of the welding process, so the electrode does not last very long, and it can contaminate the weld with carbon. An interesting side note here is that movie projectors for many decades generated the intense light needed to project a movie to the movie screen by creating an arc between two carbon rods. Unlike carbon, tungsten can hold up to the heat of the welding process quite well, and it's durable and not easily breakable. Plus, it will not sublimate and contaminate the weld. Some of you may wonder, why don't we just use a ceramic electrode? After all, ceramics hold up to heat quite well. This is true, but ceramics are not a good conductor of electricity, and that is very critical to the welding process. And there you have it. That is why tungsten is sometimes used in the welding process. It is a little bit of a trade-off on cost versus durability, but compared to other materials that could be used in the process, the durability and functionality of tungsten far outweighs the added cost of the tungsten electrodes. Thank you for watching, and as always, stay curious.